Hi, previous video we have discussed about set operation. So now we want to discuss about laws of set theory. Okay. Alright, so the function of law of set theory is to simplify a large expression. Let's say we have a large expression in the logic. So that expression we can simplify using law of set theory. Alright, so in law of set theory, we apply three types of set operations, which are union, intersection, and complement. Okay, so based on Grimaldi, we have about 10 laws of set theory. Okay, so the first one here is a double negation, where we apply the double negation here, which is A double negation, it is equivalent to A. So next we have a De Morgan's law. Okay, so De Morgan's law, and then we have a commutative laws, and then after commutative laws we have associative laws. So next we have distributive laws. Okay, so and it is followed by idempotent laws, and the seventh law here is identity laws, and then followed by inverse laws, and next is domination laws, and the last one here is absorption laws. Okay, so we will discuss further about these laws of set theory in the next slide. Alright, so if we have a complement of the whole set, which is A union B complement. Okay, so in order to simplify for this segment, we can use De Morgan's law. Alright, so how to use De Morgan's law? It is equivalent with A complement intersect with B complement. Alright, so this segment can be explained in this diagram. Okay, so here we have a subset A and B. Okay, so the square here is a universal set. Alright, so based on this segment, which is A union B complement, so the element is outside of A union B. Okay, so this is the elements area. Okay, so based on this diagram, we can split it off. Then we have about two separate diagram, which is in this universal set we have only A. Okay, so look at this diagram. So the area of a element in the red line, okay, so it is outside of A. Okay, right, so outside of A. Okay, so this one we can define it as a complement, which is the element is outside of A. Alright, so another diagram. So we have a B here. Okay, universal. So in the universal, we have another set. We name it as a B. Alright, so based on the main diagram, so the element is outside of B. Okay, so this means that uh, B, or we can say that this is a B complement because the element is lies outside of B area. Okay, so outside of B set. Okay, so this one we can define it as a B complement. Okay, so next we look at back at the main diagram. So everything is outside of A union B. So here we can put intersection operation. Okay. All right. So therefore, it has been proven that A union B, the whole thing complement, it is equivalent with A complement intersection with B complement. Okay, so next is associative law. So associative law, we work or operate with three different sets or three different subsets, and we use the same operation. Okay, so let's say we have A union B union C. It is equivalent with A union B union C, and it is also equivalent with A union B. Okay, union C. Alright, so this statement can be explained in this diagram. Okay, so originally we have A union B union C. So here we have three subsets, which are A, B, and C. Okay, so based on this statement, which is A union B union C, so it is means that these three subsets has been combined all together as a one set. All right, so as a one set. Okay, so the element is inside of A, B, and C, and we unite all of them as a one set. All right, so it is also equivalent with, all right. Okay, so A, B, C. B union C. So B union C, this one. So this is element of B union C. Alright. Okay. And we unite with A, which is A union B union C. Alright. So as we look at this diagram, so all element has been combined with these three subsets, and we have and we get a one set, which is A union B union C. Alright, so it is also equivalent with A union B union C. Okay, so we have three subsets A, B, and C. So for A union B, alright, so A union B means that we combine A and B sets, okay, as a one set. So we have A union B, and we will also unite with C. Okay, so unite with C. Alright, so based on this diagram, these three subsets have been gathered, which is A union B union C. Okay, so we can say that A union B union C, it is also equivalent with A union with B union C, and it is also equivalent with A union B union C. Alright, so this law we call it as associative law because we associate with all together. So the main point here is these three subsets must have same operation, whether it is union or it is intersection.